Okay, so last section we'll look at for this week is 2.1 and a little bit of 2.2. And this section is going to focus on zeros of polynomials. Now, we've talked about this word a couple times. Another name for zero is a root. Okay? Another name for it is called an x-intercept. So we're basically looking at where graphs cross the x-axis. So let's graph this function and figure out how many times it crosses the x-axis. Okay? At this point, I don't care where. I just want to know how many. So I'm going to clear what I have in there. Put 2x cubed minus 3x squared. Let's try x squared minus 3x plus 2. Okay, so there's my equation. Let's go zoom 6. So if we're actually looking for a complete graph, that's a good window, but all we're focused on is the number of times it crosses the axis. How many times does that graph cross? Eric? 3 times, yep. Now, we don't have to worry about, well, what if the graph goes up and then comes back down off the screen? It can. Because remember, this highest exponent, if you subtract 1 from it, tells you how many times it can turn. So this graph can turn twice. You can see both turns. There's 1, there's 2. So it's not going to turn again off the screen. Any questions on that? So it crosses 3 times. So if you look at any of those coordinates, what's the y value of any point where the graph crosses the x-axis? Yeah, 0, right? The y value of a point where you cross the x-axis is always 0 because you haven't gone up or down at all. You're right on the axis. Okay. Now, what's the x value? Well, we don't know. We'd have to figure it out. It looks like 1 is maybe -1, maybe 2. I don't know. We didn't figure that part out yet. Okay, but the y values are all 0. All right, so this part, I'm not going to go through this, but if you FOILed this out, this times this, and you did that all out, and then you'd get an answer, and then you'd have to FOIL it one more time, you would get that. Okay, so what I just put a box, in fact, I can just show you by typing it in. It's actually a quicker way to do it. Let's put in x plus 1, put in 2x minus 1, and x minus 2. Hit graph. Does everyone see how they're exactly the same? Just drew it right on top of it. So they're the same thing. This one is factored. The top one isn't. If you want to figure out where this graph crosses the x-axis, it's better to write it this way. Because what did we just say? Where a graph crosses the x-axis, the y value is what? 0. So if you take this equation we have right there, x plus 1, 2x minus 1, x minus 2, there's your formula. Y equals all that stuff. It's exactly what I just typed in. Y equals, change the y to a 0. And if you change the y to a 0, that will tell you where it crosses the x-axis. It'll tell you when y is 0. Now, if you multiply something times something times something, and you get 0, what's the only way that can happen? Yeah?
One of the values has to equal 0.
Yeah, one of the things I underlined has to be 0. Either the first one has to equal 0, or the second one has to equal 0, or the third one has to equal 0. If the first one came out to 0, what would x have to be? Negative 1. Now, look at the graph. Negative 1. That's where it crosses for one of my x values. What about the second one? To make the second one 0, what would x have to be?
Negative 0.5.
Let's see. Close. Yep.
0.5.
0.5, 1/2. 2 times 1/2 is 1, 1 minus 1 is 0. And if you go back and look at your graph, 0.5. What value of x would make the last one 0? Yeah, 2. Look at your graph. 2. So, okay, point I'm trying to show you here is that if you can factor, okay, here's a nice little extra copy of that graph, but if you can factor your, maybe it'll go away. Okay, so point there is if you can take an equation and you can factor it, it makes it very easy to figure out where it crosses the x-axis. What if you can't factor it? Then it's harder. Okay, then it gets a little harder. So we could use a calculator, because the calculator wouldn't have cared if these answers came out nice or not. Even if they were decimals, the calculator would have still given us the answers. Right? But factoring it makes it so we can do it easily without a calculator. So we found 3 numbers that were solutions to the equation when we set it equal to 0. We got, what did we get again? Negative 1, 1/2, and 2. So those 3 numbers basically tell us the coordinate of the x-intercept. One x-intercept is 1/2, 0. Another one was negative 1, 0. And another one I think was 2, 0. Okay, so when you write your answer like this, you're giving me the coordinate of the x-intercept. If you write the answer as just a single number, you are just telling me the root, or the 0. All right? So the difference on the test is if I ask you for the x-intercept, you need to give me a coordinate. Okay? If I ask you for the root, or the 0, you just have to give me that number of the x-intercept. Does everyone understand the difference between if I ask for an x-intercept or I ask for a 0 or a root? They're really connected, but they're just slightly different. Okay? So let's think about a line. Okay, we're going to start with the simplest kind of equation and then work our way up to more complicated. Okay, we just did a pretty complicated one. That was cubic. But a line can cross the x-axis. Assume it's not horizontal or vertical. Okay, just a line in y equals mx plus b. How many times can a line cross the x-axis? If it's not horizontal or vertical. Yep. Once. Just once. No matter how you draw your line, if it's not horizontal or vertical, it would only cross once. Now, even if it's vertical, it would still only cross once. But horizontal can get kind of weird. Horizontal might not cross at all if it was parallel, or if it was exactly on top of it, then it crosses an infinite amount of times. Okay, but we're just looking at a case where it's not horizontal. So, we got an equation like this. Y equals mx plus b or ax plus b. The letters don't really matter. How would you get x by itself here? What would be your 2 steps? Yeah.
Subtract b and then divide ax.
So subtract b. Yeah, I like that. and then divide by, yep. So if you had like 3x plus 2 equals 0, and you minus 2, you wouldn't divide by x now to get x by itself. A. You divide by the number in front. So minus the b, divide by the a. That's pretty much how you solve any linear equation if it's in slope-intercept form. Okay, so let's try an example where we figure out where this line crosses the axis. Okay. So, anyone think they can tell me where this graph, or, yeah, tell me the answer to that equation. Chris?
Negative 1.5.
Yeah, negative 1.5, or if you left it as a fraction, what would it be?
Negative 1.5. Wait, negative 1.
Yeah, negative 3. I would write negative 3 halves, just because we usually don't use mixed numbers, but okay. Yep, so that's good. So what did Chris just tell me? Negative 3 halves is the what of this equation? Yep.
Root.
It's the root. What's another word for it? He also gave me the
0.
Now what if I said solve and tell me the coordinates of the x-intercept? What would be the coordinates of the x-intercept here?
Negative 3 over 2, 0.
Negative 3 over 2, comma 0 in parentheses. Okay, so that's a linear equation. All right, so now let's step it up 1 degree to a degree 2. Eric, when your highest exponent is a 2, what kind of equation is that?
Quadratic.
Yep, it's a quadratic. So now, same question I asked you about linear equations. How many times can a quadratic cross the x-axis? Yep.
Twice.
Could cross twice. What else? Are there any other scenarios that could happen? Yep.
Once.
Could cross once. Yeah.
Or no times.
Or no times. Remember when we did the discriminant yesterday? We did that b squared minus 4ac. We had 3 conditions. One resulted in no solution, 1 solution, or 2 solutions. So we talked about that. I think when we right when we finished going over the homework yesterday. So you either get 0, 1, or 2 solutions. So let's see if we can solve solve this one. 2x squared equals 1 minus 2x. Okay, I'm going to do this one with quadratic formula because we haven't practiced that in a little bit. And then if we want, we can do it with graphing after. If you want to solve a quadratic for the zeros, what number do you have to get your equation equal to? 0. Yeah, you got to get it equal to 0. I would move everything to the left because I always like this number to be positive. Just like if I'm going to factor, that's what you're looking for. I don't think this is going to factor, but that's how I still do it. Put everything on the left. And Jacob, how are you going to move the 1 to the other side? Subtract it. And how about the negative 2x? Add it. Okay. So let's see. Could we could try to factor that because remember the first problem I gave you? It was factored. I just factored it for you, and it made it very easy. This one I don't think is going to factor. You could try 2x and x and 1 and 1, but I don't think it's going to work. So we're going to use quadratic formula. Okay, Nikara, what's a here? 2. 2? And Chris, b?
2.
2. And Elias, c? Not sure? So, do you see where C is in that first line there?
Oh, okay.
So just look for that number that's in that spot in that equation in black. Negative 1. Yep. Okay. Now we'll fill in the quadratic formula. So negative b plus or minus what comes next. This is the thing that we used yesterday. Yep.
The square root of b squared is 4ac.
The square root of b squared, good. Minus 4ac. And that's all divided by Emily? 2 times 2, yeah, 2a, which in this case is 2 times 2, or 4. Okay, so let's do that up. Minus and a minus. You're going to have negative 4 times another negative number. It's going to turn into a positive. What's 4 times 2 times 1? 8 plus 4? 12. And now since they said solve it approximately, that means you can round that off. So now type it in. Let's see what we got. So we've got 2 plus the square root of 12. That's the top. And then divide by 4. Okay, that's one answer. 1.37. Or, type it in again. Negative 2 minus the square root of 12. That's the top. Divided by 4. Negative 1.37. It doesn't matter if you list the lower answer or the higher answer first, as long as you list both. Okay. Any questions on that?
Where did the 12 come from?
The 12 from this calculation right there. 4 plus 8.
4.
Now, if we wanted, I'm not going to do it this way, but if you wanted to do it on the calculator, I would put that in y1, put that in y2, and then what feature could you use that we've used before? You put what's in red in y1 and what's in green in y2. All right, maybe we should do it. So let's get rid of all that. So 2x squared and 1 minus 2x. But put it on a new line. So how would I get those same two answers I just got using what I have on the screen there? Eric?
Trace button.
Alright, so you could kind of trace, but it won't give you an exact answer. It would kind of give you an answer that's close. How can I get an exact answer? There's something
Was
built.
it the second trace or
Yep. And then what?
intersect?
Intersect, yep. So, pick a point on the blue, the red, do your guess. Negative 1.37. It's exactly what I got using quadratic formula. The other answer, I think it was positive, I don't remember exactly what it was. Positive 1.37. So any questions on that? Yeah. So I graphed each equation, one in y1, one in y2, and then second calc, and then you can go intersect. And you should be able to get both your answers that way. Do we get one that's a little 2x squared and 1 minus 2x? Let me just double check my arithmetic, make sure I did everything right. Let's do 2 plus square root of 12 divided by 4. So yeah, we should get one answer at 1.37, and the other one should be negative 1.37. Are we getting something different?
Yeah, you put negative minus, so that's probably why. Different. That's more accurate.
Negative 0.36. So,
Getting positive.
what did I type wrong? 2 minus the square root of 12. And then divide that by 4. So we get negative point. Why is that coming out negative? Let me just double check our numbers. A is 2, yep. B is 2, C is negative 1. So negative b plus or minus square root of b squared. And that was a minus, but we've changed it. So 4 times A times C all over 2A. Yeah, so everything there is looks correct. You're going to have negative 4 times 2. Right? That's negative 8. Times negative 1 is positive 8. And then 4 plus 8 is 12. Yeah, so I'm pretty sure. Let me double check the answer. But yeah, we did everything right with the quadratic formula. So it says the x-intercept should be about negative 1.4. That's one that we got. And 0.4.
Yeah, that sounds about right.
Negative 1.4 and 0.4. So, yeah, if you look at the graph, that looks right to me. Negative 1.4. And let's see if that one is 0.4. So, second calc.
It's like 0.36.
It comes out to 0.36.
Yeah, like 3.6.
Okay. Yeah, so the graph is matching what the book said. So, how come I'm not getting 0.36 right here?
I think it's because you forgot the negative 2 and you're putting like a positive 2.
Oh, that, you know why I did that? Because I'm looking at it on the calculator and I couldn't
like
see the
big
negative.
positive.
And then I've tried moving the calculator and I can't. So I just said, heck with it, I didn't move it. That's why. Okay? Yeah. So it should be negative 2, now that I can kind of see it, plus the square root of 12 divided by 4. There you go. There's the other answer, 0.37. So 0.37, and then I think the other one was negative 1.37. Yeah. So now we're good. All right. So you can solve it either way, as long as make sure your calculator is not on top of your paper and you can't read your numbers. So finding roots graphically. Okay? So basically, remember the way we have to do it is, I'm just going to say like this. Use the root or the 0 feature of the calculator. Okay? We do second calc, mine says 0. Some calculators say root. Doesn't matter, it's the same thing. Okay, so that's the best way to find roots graphically. All right, let's do this one graphically. Okay, so I want to type this in. Can someone tell me what I would type in here? How would I do this one? Okay. And that's x cubed. If I try to get over that. Yep, x cubed plus 2x equals 1. So what would be my set of steps to do this? How about Alex? Can you tell me what I would do first?
Plug in the numbers to the quadratic.
No, that's not a quadratic, right?
Oh,
That's a cubic. So we have to solve, and the only way we know how to solve a cubic is we're going to do it graphically.
oh, right.
So how would I do this problem on my calculator? And it's gonna be the same way we did the last one. I'm gonna do the same kind of thing. Not sure? Yeah?
We have to get it all onto the same side first.
There's two ways you could do it. You could either keep it the way it is, or you could put everything on the same side. Which way do you want to do it?
Let's put it all on the same side.
Okay, let's put it all on the same side. So if we put it all on the same side, can you tell me what we'll have?
X cubed plus 2x minus 1 equals 0.
Yeah, perfect. So we get it all on the same side. Now, what do I do with that? Yep. Yeah, where do I type it in?
Y equals.
All right. Put it in on y equals. So it's x cubed plus 2x minus 1. So x cubed plus 2x minus 1. All right. Now what?
Go to your graph.
All right, let's go to my graph. All right. Okay, so I'm trying to find where this graph equals 0. Jacob, what does that mean if we're trying to find where the graph equals 0? We're looking for the what of this graph?
The x-intercept.
Exactly. All we want is the x-intercept. All right? So how do I get to a menu that can find the x-intercept for me? What do I have to press?
Second trace.
Okay.
0.
Yep. And since we put everything on one side, we're going to do a 0. If we had left it the way it was, with something on the left and something on the right, we then would have looked for where they cross, like we did in the last one. But we put everything on one side, so we're going to calculate where it's equal to 0. Pick a point that you know is somewhere to the left of your x-intercept. Doesn't matter how far to the left, just definitely to the left. Pick a point somewhere to the right. Now it's going to look between those two dotted lines for where the root is. Just put your guess kind of close, and you get about 0.45. And that's it. So, any question on how to find a root on the calculator? So, method 1. Put what's on the left in y1, put what's on the right in y2, see where they cross. Method 2 is the way Brandon just told us. Get it equal to 0, type it all in on y1, and then use second calc 0.
Is the test going to be like some of both, like calculator and non-calculator for the other ones? Or?
Yeah, there'll be a little bit of both.
Okay.
Yep. Problem like this you definitely can't do by hand because it's a cubic. There is a thing called the cubic formula. Most people don't know it. I don't know it. It's kind of like the quadratic formula, but it's a little more complicated. All right, so third degree polynomials. This is like the first problem we looked at today. How many times can a third degree polynomial turn?
3 or 4?
No, not that many. Not quite that many. Yeah, Emily? 2. Third degree polynomials can turn twice. Doesn't mean they have to. That's just an upper limit. They can turn twice. So this is what third degree polynomials could look like. Okay. The ones on the left, they kind of start to turn, but they never really make a turn. They just level out a little and keep going. Right, so these are 4 different examples of cubic graphs. 1, 2, 3, 4. Now, how many solutions could you have at most for how many times this crosses the x-axis?
1.
At most, yep,
3.
3.
Oh, I thought.
There's your x-axis right there, so you could definitely get 3 crossings. What's another amount of crossings you could get? Yep.
1.
You could get 1. Anything else?
2.
You could get 2 if it was just like that. So could you get 0? No. It goes up and down forever. So no matter where you put this line, it's going to hit somewhere, at least once. Okay? Unlike a parabola, parabolas do not go up and down forever. So I think I'm going to hold off on this one. But is there any questions on how you would type that in? It's like the first one we did. If it just said type it in and asked you how many solutions it has, you're just looking for how many times it crosses the x-axis. And it could be any of the 3 you guys just said. Once, twice, or 3 times. Any question on how to type that in? Now, let's say it crossed 3 times, because I know it does. So, if it crossed 3 times, and I asked you to find the answer for the root that's in the middle, what do you do on the calculator to find where it crosses the x-axis? If I wanted all 3 answers, you'd have to do this 3 times. But I'm just asking you to find the one, maybe it looks something like this. That's the one in the middle. What do you have to do?
Well, you have to go to second trace, then
Yep.
put your left bound between the left and the middle.
So before you hit, so you second trace, and then what do you pick onto that screen?
Oh, 0.
Yes. So second trace 0, you pick a point that you know is to the left of your root. And then what were you saying?
To the right of your root.
Right?
And then move the guess thing to as close to
Yeah.
that as well.
So now it's going to give you the one in the middle. If you wanted the one on the left, which is over here, and the one on the right, you got to do that same process 3 times. It's the only way to do it. Okay? And we did that in the last problem with what Brandon just told me. So we just practiced finding a root. All right, so last thing we'll look at, and we're not going to do much of it, is really just going to be one question on the test from this section. Okay, it's going to be the very last question. Yeah?
So, sorry, for the question of the previous thing, you just write the coordinates, or?
Let me read the directions. It says find the root, so all you have to do is write the number. If it said find the x-intercept, then you would want to write the coordinates. Yep. All right, so this part, I mean, I don't think you need to write it, you can just really read it. But just remember, when you're setting up a problem on the calculator, when you have a real-world problem, sometimes certain values don't make sense. Okay? So what this is saying is when we make a graphical representation of a problem, that's usually something we do, make a graph, keep in mind that like negatives might not make sense. Like negative time, negative money, all right? So you may see negative values on your graph, but you got to think of it in the terms of like the real problem you're doing. Do negatives make sense? Negative distance? No, doesn't make sense. All right, so when we go through the problem we're about to do, step 1 is going to be set up an equation. That's the algebraic part. And then step 2, we're going to use a graph to help us solve something about that equation. So we're going to do a combination of making an equation by hand and then using the calculator to figure out something. So, for this problem, Bill is going to invest $20,000. Now he has 2 investments to pick from. One of the investments he can pick from pays 6 3/4% interest. That's the amount he's going to make on his investment. And the other investment pays 8.6. Now these investments, the way they work, it's a simple interest investment. It's kind of like how a savings account works in the bank, but we're going to actually simplify it a little bit. Banks use what's really called compound interest, but that would make this problem a little more complicated. So Bill's got 2 investments to pick from. He's got $20,000. He can put as much money as he wants in one and the rest in the other. Okay? So first thing you need is the formula for simple interest. Okay? And when you make your reference sheet, I would put this on there. The formula for simple interest is I equals PRT. Okay. I is how much interest you make. P, that's called the principal. The principal is how much money you invest. All right? Or if you had a savings account, it's how much money is in your savings account. It's the principal. R is the rate of the investment, but the rate has to be as a decimal. So if you had like 5%, how do you write 5% as a decimal? 0.05, yep. Or 0.08 if you had 8%. Okay? So you got to change the rate to a decimal, and T is the time. Time is usually just measured in years. Right? So, find an equation, that's what algebraic representation means. Find an equation for how much interest Bill will earn in 1 year. Total interest. How many investments does Bill have to pick from? 2. He's going to earn some money in the first investment. He's going to earn some money in the second investment. To find the total that he earns, what would you do with the money that he earns in each one? Yeah.
Add them together.
Yeah, you add them together. So his total interest that he makes is the amount of money he makes in the first one plus the amount of money he makes in the second investment. Now, we don't know how much money he puts in either one of them. All we know is he has a total of how much money? 20,000. He can split it up any way he wants. He could put 19,000 in one, he could put 1,000 in the other. He could do it equal, 10,000 and 10,000. Since we don't know how much money he's going to invest, let's let X be the amount of money that he puts in the 6.75% investment. Now, if you wanted, you could have said let X be the amount of money he invests in the 8.6? It doesn't really matter. It would just control which variable you're solving for first. Eventually, you're going to solve for how much money he puts in each investment. Okay. So, let's start with the amount of interest that Bill earns in the 6.75% investment. So the interest he earns is equal to, what's the first thing in the interest formula? The first letter? P. P is the what? It's the principal. It's how much money he's going to invest. How much money is Bill going to invest at 6.75%? We might not have a number, but they told us how to represent
X.
X. The next thing in the interest formula, P, what letter comes next?
R.
R.
6.75.
So what's my rate here? Yep.
0.067.
Yes. 0.0675. It's got to be a decimal. And what's the last thing you need?
Time.
T. So it would just be times 1. So in this case, I really don't need to put times 1. I mean, you can. And now when you simplify that, you get this. That's a formula for how much interest he's going to earn if he invests X dollars at 6.75%. Any question on that one? Now, he has the other investment. So whatever money he has left over is going to go here. All right, so let's see how much interest he earns here. First thing you need is the principal. How much money does Bill have left over to invest here? Think about how much he already invested. Think about how much he had in total. And just tell me what's left from that. Yep.
We'd have to use a different variable, right? Because we didn't put the same amount in.
It's going to be a different amount, but you're going to use that same letter. Yeah?
Would you still like use it as a single letter, or would you use two different ones?
No, you're still going to use the same letter. But you got to think about how much money he had to start with and how much he already invested. And then do a little arithmetic. Yep.
Maybe 20,000 minus x.
Yep. So he had 20,000 and he already invested X dollars of it somewhere else. That's how much money he has left. That's his principal here. So there's your principal. What's my rate when I change 8.6%? Yeah.
0.086.
Yep, good job. And again, the time is 1 year, which you don't really need. Now, this 0.086 is on the outside of parentheses. So what can I do with it to simplify that a little bit?
Distribute.
Yep, distribute it. So I'm going to write x1 first. Negative 0.086x plus, now I need 20,000 times 0.086. So 20,000 times 0.086 is 1720. Okay. So there is a formula for how much interest Bill earns in the other investment. Now, they want us to write a formula for the total. So what am I going to do with each formula to find the total interest? Yep.
Add them.
Add them up. So the formula from the first investment is 0.0675x. The interest from the second investment, negative 0.086x plus 1720. Do I have any like terms I can add together? Okay, yeah.
The x's.
Yeah, we can add the x's. We've got 0.0675 plus negative, so I'm just going to say minus 0.086. That's negative 0.0185 plus 1720. So that is a formula for the total interest Bill will make. And for this part, that's all they want. The last part, we're going to graph that and then look for an intersect on something. Okay. So remember, when we graph it, think about x. X was an amount of money invested. What values wouldn't make sense for x? Yeah. Negative, yeah. Can't invest negative. How about an upper limit? Is there an upper limit on how much he can invest?
20,000.
Can't go past 20,000. Doesn't make sense to look at if he invests 30,000. He doesn't have 30,000. Okay. So we can, let's set our window. 0 to 20,000. Okay. The y min and max, that's going to depend on what they tell us in the next part. Okay. But we can put the equation in if we want. What was it? Negative 0.0185x. Negative 0.0185x plus 1720. What is that 1720? If you think of this as like y equals mx plus b. Yeah? The y-intercept. It's way up at 1,720. Am I going to see it on the screen? No. So I would set the y-max. Let's set the y-max a little higher. Let's put it up at 2,000. So remember, this is your y value right here. It's what's on the other side of the equation. Can total interest be negative? No. This isn't the kind of investment where he could lose interest. He's only making interest. So doesn't make sense to look at negative interest. Okay, hit graph. All those different amounts on that line represent how much interest he can make. And the reason it goes down is because the more interest he puts at a lower rate, the less money he makes. Right? If you invest money and you put more of it in an account that's going to pay less interest, and you don't pick the account that pays higher interest, you're going to make less money. It would have been better if he just put all his money in the 8.6. But maybe for some reason in real life, there'd be a risk. Maybe the one that pays more money, there's a risk of losing money. Where, we don't know, all right? But we got our equation. And now, the last part says, how much money did Bill invest in each investment at the 8.6 and 6.75? So how much money did he invest in each investment if he ended up making $1,509.10 in total interest for the year? So, look at our equation. Where is that $1,509.10 going to go in my equation? Where would I plug it in?
Total interest.
I'm going to plug it in right there. So let's do it. $1,509.10 equals, and then copy down the rest. Now, I already put this in Y1. Where am I going to put that?
Wait. Oh, in your table. Oh.
So I put what's on the right in Y1, right? Let me double check. Make sure. Yeah, I got that in Y1. What about the 1509? Yeah?
Y2.
Put it in Y2. Okay. 1509.10, 0.1, doesn't matter. Okay. Now what would I do?
Find the intersection.
Find the intersection. Second, calc, intercept. Blue, red, guess. 11,400. I just solved for x. Alright, so x equals 11,400, and that's dollars. Now, when we started this problem, x meant something. What was x again?
Alright.
Well, it's an amount of money, because it has a dollar sign on it. But what amount of money is x? Yeah.
The lower interest rate.
So it's the amount of money invested at 6.75%. So that much money he put in the lower one. How would I figure out how much money he put in the higher one?
Subtract that from 20.
Yeah, just take his total money and subtract what he put in the lower one. So if he put 11,400 in the lower one, he put 8,600 in the other. What was the other interest rate? 8.6. And there's your two answers. Now you didn't have to use a calculator to do this last part. You could have, you definitely could just solve this equation by hand. Just subtract 1720 to the other side, and then divide by negative 0.01. But I wanted to use a calculator. All right. So what I'm going to do the last 5 minutes, I'm going to put up the homework and tell you the kinds of problems you're going to see on the test tomorrow. So the first part that we started with chapter 2, that's on page 82. And the second part that we we just did at the end was page 88. All right, so kinds of things you want to make sure you know for the test. I'm not going to be able to go through how to do everything, but I'm just going to tell you what they are. Evaluate a function. I give you a number, I give you a formula, you know how to plug it in and tell me the answer. Find domain. Keep in mind things you can't do. Square roots of negatives, divide by 0. That's important. Find the equation of a line. We practice finding lines that were parallel, we did perpendicular. Parallel, perpendicular. We also did special cases. What's a special case? Y equals 2. That's a horizontal line. X equals 3. That's a vertical line. Everything else is y equals mx plus b. Transformations. So we spent a whole day on those. Make sure you know transformations. Composition. That's like f of g of x, plugging something in like that. Domain, I'm also going to add range to that. So domain, range. There's going to be a word problem about a rectangle. So you should be familiar with the area. You're going to have to know length times width, but you can make a reference sheet. Calculate zeros using the graphing calculator. Okay, we did a little bit of that today. And then I would definitely know this interest problem. You're going to have a problem very similar to this last one on the test. Okay, so those are the topics that are on this week's test. Okay, if you have any questions on them, you can always just come see me after school, and I'll go over whatever you need to go over.